In this example, what we're going to do is we're going to find out the length of a metal support for a bridge. The metal support is in bold, but I'll highlight it in yellow just so that you can see it. Now, thankfully, we can treat both parts as part of a right angle triangle, so we can use the Pythagorean theorem. Let's take a look at that first triangle. Remember, the Pythagorean theorem is a squared plus b squared is equal to c squared. Alright, so using the information available to us, that's going to be 4 squared plus 6 squared is equal to c squared. So that's 16 plus 36, which is equal to 52. Now remember, c squared is equal to 52, so we have to take the square root of that in order to get rid of that squared sign. So c is equal to root 52. I can change this into a mixed radical, but I will leave that to the end because we do have a second part. This here is a second triangle. It's a little bit bigger. Same thing though, we're using the Pythagorean theorem. A squared plus b squared is equal to c squared. Let's put in the information we've been given, so that will be 8 squared plus 12 squared is equal to c squared. So 8 squared is 64, and 12 squared is 144, and your answer is going to be 208. C squared is equal to 208. So you have to take the square root again, because all we want is c. So c is equal to the square root of 208. Alright, so here is the two pieces of information that we received. We know that one side, the small side, is root 52, and the large side is going to be root 208. Now we can't collect these right off the bat because the radicans are different. However, if we switch them into mixed radicals, then we can collect them. So if you break down root 52, that's going to turn out to be 4 times 13. 4 is a perfect square. You can bring that out. Now that's going to be 2 root 13. This gives you a little bit of a hint for the second one. Since we're trying to collect these, try dividing this by 13, the 208 divided by 13 to see what you get. You should get 16 times 13 being your answer. This, of course, is a perfect square, so you can bring that out. So what you're left with is 4 root 13. Add those together because the radicans are now the same, and you're left with 6 root 13 as your answer.